Hi, I'm Brian with Louisiana 4-H's Youth Wetlands Program. Today we're going to be doing an experiment on ocean acidification. Here are the materials that you're going to need. You'll need white vinegar, some simulated ocean water. I've used 1.5 teaspoons of salt per cup of water here, a couple of glasses, and lastly, you'll need a couple of seashells. You could also use an egg if you don't have any seashells at home, because they're made out of the same thing.
Before we begin, let's quickly talk about acidity and why it's a problem for our oceans. When we say something is acidic, what we mean is that there are a relatively large amount of hydrogen ions. So the more free hydrogen ions there are, the more acidic we'd say something is. These hydrogen ions are pretty reactive, which means they freely interact with other molecules very easily. Our oceans have increased in acidity about 30% since pre-industrial times. Why is that? Well, as we burn fossil fuels, we release carbon dioxide into the atmosphere. A lot of this carbon dioxide ends up being dissolved in the ocean, which raises its acidity. So why does this matter in our oceans? All life in the ocean depends on having the right amount of acidity. We can take a look at mollusks, for example. These organisms build many of the seashells you find on the beach. The shells are made of a substance called calcium carbonate. Mollusks are able to make this molecule out of carbonate, which is naturally in ocean water. But how does carbon dioxide raise the acidity of the ocean, and why does it matter? Well, let's get back to our mollusks real quick. Remember, they need carbonate in order to make their shells. Picture the air outside with a lot of carbon dioxide molecules in it. The ocean is going to dissolve the carbon dioxide from the atmosphere. In the ocean, carbon dioxide is hanging around water molecules. Carbon dioxide can react with water to form carbonic acid. Carbonic acid itself is pretty weak, and it loses one of its hydrogen atoms pretty easily. What's left is called bicarbonate. Alright, so this is where things get interesting. Remember, we said acidity was an increase in hydrogen ions, and that these hydrogen ions were fairly reactive. Lastly, we also said that mollusks require a supply of carbonate to make their shells. The hydrogen ions react with carbonate, turning them into bicarbonate. With less carbonate in the oceans, it's harder for mollusks to make their shells. Let's get back to the experiment. Take your seashells and make some observations. Color, hardness, and the weight if you're able. Place them in the bottom of 2 glasses. Cover one shell with your simulated ocean water and the other with vinegar. What do you notice? See all the bubbles coming from the shell in the vinegar? Vinegar is acidic, and those hydrogen ions are reacting with the shell. As they react, it releases carbon dioxide as byproducts. That's the bubbles that you're seeing. Check back on your shells occasionally after 1, 12, and 24 hours, and continue to make observations. Here's a look at our shells after 24 hours. You can see the shell in ocean water is unchanged. However, you can see the shell that was placed in vinegar is nearly all dissolved. Scientists are definitely concerned about our ocean's rising acidity and its effect on marine life, but what can we do? Remember, the increase in acidity is caused from carbon dioxide, which is released as we burn fossil fuels for energy and transportation. Think about ways you can save energy at home. Turn off the lights when you're no longer in the room. Turn up your thermostat in the summer or down in the winter. Find ways to burn less fuel, like carpooling or biking. Our small individual actions can make a big difference.